Hello students, under the topic linear programming problem, here we are going to learn the bounded variables algorithm. A linear programming problem may have, in addition to the regular constraints, a type where we will be having the lower and the upper bound. Now here in the constraints you may see that the non-basic variables are having lower limit and upper limit. So we understand that the given problem it has to be solved by using bounded variables algorithm. And in particular in this problem, the non-basic variables have a positive lower bound, which means that we have to use the upper bounding algorithm in order to solve this given problem. So here are the steps involved in solving this given problem. The first step is we have to convert the minimization linear programming problem into a maximization problem. So if you see here, the given question is already a maximization problem. Therefore, here we need not have any conversion because the given problem is a maximization problem. If suppose it is given as a minimization problem, then the first step will be to convert the given problem as a maximization problem. And then we proceed with the next step. The next step is if any bi is negative, convert it into positive by multiplying both sides of the corresponding constraint by -1. We see that here we have the constraints where the values of bi are 14 and 43, and we see that both the values are positive values. So here if suppose we have negative values, then we have to convert it into positive values by multiplying with a -1 on both the sides. So that step is not necessary here now. The third step is if any of the variable is at a positive lower bound, we have to make a substitution. And how the substitution will be? The substitution will be done for the lower bound by Lj is equal to xj minus xj dash, where Lj is the lower bound, xj is the variable that has been given in the question, and another variable xj dash we have to introduce. That is, here if we check in our given problem, here we have the non-basic variables x1, y and x3. What are the bounds for x1, 0 and 4? So we have to check out for the lower bound. Here the lower bound is 0. So we need not make any substitution. And here also for x3 the lower bound is 0. So we need not make any substitution now. But if you see here, the lower bound of the variable y is 7. So we need to make a substitution now. So what the substitution should be? It should be Lj, that is the lower bound first we have to write. So let us write that. So I have written here, since y has a positive lower bound, so how we have to make the substitution? First the limit Lj. So what is the lower bound for y? It is 7. So that we will write. So 7, and then that is equal to, so the substitution has to be made in such a way that, so 7 is equal to, now if you see, xj is the variable that is given in the problem. So what is the variable that is given here? Y. Minus, we have to introduce another variable. So since we are having x1, x3, I am going to introduce a new variable x2 over here. So we have to make a substitution for where we have to substitute the lower bound is equal to the given variable minus the new variable that we are going to introduce. So from this what we get? We get the value of x2 to be equal to y minus 7. Also we can say that y is equal to x2 plus 7. So this is the substitution that we are going to make. So I hope you would have understood how we got it. Okay, so y is equal to x2 plus 7 is the substitution that we are going to make for y in order to make the lower bound 0. So when you substitute this, what do you get over here? 7 will be lesser than or equal to, the substitution is x2 plus 7. So x2 plus 7, and that is lesser than or equal to 10. So now since we have this plus 7 over here, when we distribute it to both the sides of the inequality, 7 minus 7 will be lesser than or equal to x2, lesser than or equal to 10 minus 7. And so what will be the bounds now? 0 lesser than or equal to x2, lesser than or equal to 3. Therefore, the lower bound has been made as 0, and the substitution that we have made is y is equal to x2 plus 7. So when we make this substitution, the given LPP will be reformulated. That is, at the place of y, we have to replace it by x2 plus 7. So here in the constraints also we have to make the replacement, and so the given question will be reformulated and we will get the new LPP. So let us write that. So the LPP will become, so if you see here, we have maximize z is equal to 3x1 plus 5y plus 2x3. So at the place of y, I am going to put x2 plus 7. So what I will get? So at the place of y, I have substituted x2 plus 7. So the problem will be reformulated as max z is equal to 3x1, and on multiplying this plus 5x2, and I will write this 2x3, and I will write the constant, that is plus 35. So this is the new problem, and subject to the constraints should also be reformulated. So at the place of y, I will have to substitute x2 plus 7, and so the constraints will be reformulated as subject to, we will have x1. Now at the place of y, we have to substitute x2 plus 7. So x2, I will write the 7 here. So x1 plus x2 plus 7 plus 2x3 is lesser than or equal to 14. And so taking this 7 to the right, we will be getting x1 plus x2 plus 2x3 lesser than or equal to 14 minus 7. So 7. So this will be the first constraint. So this is the problem and this is the constraint. And what is the next constraint that we have? 2x1 plus 4y plus 3x3 lesser than or equal to 43. So at the place of y, we have to replace it by x2 plus 7. So what we will be getting is 2x1 plus 4 multiplied with x2 plus 7 plus 3x3 is lesser than or equal to 43. Now this becomes 2x1 plus 4x2 plus 28 plus 3x3 lesser than or equal to 43. And further simplifying this, we will get 2x3 x1 plus 4x2 plus 3x3 is lesser than or equal to, taking this 28 to the right, we will be having 43 minus 28, that is 15. So this is the second constraint. And then we have the inequality. So we can just write these inequalities, that is 0 lesser than or equal to x1 lesser than or equal to 4. And then instead of the inequality 7 lesser than or equal to y lesser than or equal to 10, we have to replace it by the new reformulated, that is 0 lesser than or equal to x2 lesser than or equal to x3. So that we have to write. So 0 lesser than or equal to x2 lesser than or equal to 3. And then we have the next inequality, which is this. So that one we have to write. So 0 lesser than or equal to x3 lesser than or equal to 3. So we have reformulated the question as max z equal to this with respect to the constraints. This is the first constraint, this is the second constraint, and the non-basic variables x1, x2, x3 has the bounds. X1 has the bounds between 0 to 4, this is 0 to 3 and 0 to 3. So I have taken and I have written the reformulated problem. So now using this, we have to proceed the problem further. So the next step involved is, by introducing slack and surplus variables, express the given LPP in standard form and obtain an initial basic feasible solution. So as we proceed in simplex method, we have to write the standard form of the given LPP. introducing the slack or surplus variables accordingly. Now if you see, the inequalities here are both lesser than or equal to, so we need to introduce two slack variables since we have two constraints over here. So let us introduce. So the standard form will be max z is equal to 3x1 plus 5x2 plus 2x3, and since we are going to introduce two slack variables s1 and s2, it has to be added with coefficient 0 in the objective function. So 0s1 0s2 plus 35 subject to the constraints. Now this inequality constraints will turn out to be equality constraints when we add the slack variables. So x1 plus x2 plus 2x3, and we have to add slack variable s1 with coefficient 1 in the first constraint, and slack variable s2 with coefficient 0 in the first constraint, and that is equal to 7. And in the second constraint, so 2x1 plus 4x2 plus 3x3, and the slack variable s1 should be added with coefficient 0 and s2 with coefficient 1, and that is equal to 15 in order to form the matrix 1 0 0 1. So we have uh, converted this inequality constraints to equality constraints by adding the slack variables. And then here we will be having the non-negative constraint, that is 0 lesser than or equal to x1 lesser than or equal to 4, and 0 lesser than or equal to x2 lesser than or equal to 3, and 0 lesser than or equal to x3 lesser than or equal to 3, and for the slack variables 0 lesser than or equal to s1 lesser than or equal to infinity, and for s2 0 lesser than or equal to s1 lesser than or equal to infinity. So these three variables are non-basic, and s1 and s2 are basic variables. So after writing the standard form of the LPP, we have to find the initial basic feasible solution. So the initial basic feasible solution is obtained by putting the non-basic variables x1, x2 and x3 as 0 in the constraints that we have. So if in the first constraint, if we put x1, x2 and x3 as 0, we obtain s1 to be equal to 7. So s1 is equal to 7. And in the second constraint, when we put x1, x2 and x3 here, x1, x2, x3 as 0, we get s2 to be equal to 15. So s2 is equal to 15. So this gives us the initial basic feasible solution. So until here, step 4 is completed. So we have found the initial basic feasible solution. The next step is step 5. Compute the net evaluations Zj minus Cj and examine the sign of Zj minus Cj. So this is the usual simplex method steps that we are continuing with. So we have to compute the net evaluations in the next step. So we shall begin the problem with the initial iteration. Now here we have the simplex table. Let me explain you one by one, that is each of the columns. The first column is CB and the next column is YB. So we will start with this column YB. So what is this column? These are the basic variables that we have initially. So what are the basic variables that we have initially? It is S1. So we will write that, and S2. So these two are the basic variables that we have initially. And XB is the solution space. So what are the initial basic feasible solutions that we have obtained? Here we have, that is this 7 and 15, this matrix. So 7 and 15. So that was the initial basic feasible solution that we obtained, 7 and 15. So that we have to write here. So here 7 and here 15, because S1 was equal to 7 and S2 is equal to 15. And CB is the cost of S1 and S2 in the objective function. So this is the objective function. Now what is the cost of the variable S1 and S2 in the objective function? They both are 0. So this has to be 0. So this is for S1 and S2, the cost in the objective function. And then here we have x1, x2, x3, which are non-basic variables in S1 and S2. So this matrix has to be filled by using the that is, here we have 1 2 1 4 2 3 1 0 0 1. So these values has to occupy this. So if you see, I have taken and written 1 2 1 4 2 3 1 0 and 0 1. And then here we have Cj. Now Cj we have to start with top of this xb, which is the solution space. At this place we have to check out for the constant that has been added here, that is 35. So that was the constant that we have in the objective function. This 35 we will write with a negative sign over here. So minus 35. So this step you should remember. And x1, x2, x3, s1, 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 s2, all these values will be taken from the objective function, that is the coefficient of x1 is 3, which we have to write over here for Cj, that is the cost of x1 in the objective function. The cost of x2 in the objective function is 5. So that we have to write here. What is the cost of x3 in the objective function? It is 2. So that we have to write here. And the cost of s1 and s2 in the objective function are both 0. So this has to be filled with 0. So, and then you could see that I have added a new row over here, and this row represents the upper bound of these variables that we have. That is, it is represented as UR. The upper bound is represented as UR. What is the upper bound for x1 in the given problem? Now if you see, the upper bound is 4. So that we have to write correspondingly. What is the upper bound for x2? If you check out, it is 3. So that we have to write here respectively. The upper bound of x3. Upper bound of x3 is 3. So that we have to write here. And for s1 and s2, we see that the upper bound are both infinity. So I am writing infinity over here. You may also, we need not write. Okay, so we can also write over here. And since 4 is corresponding to x1, we can name it as u1, this is u2, and this is u3. And so now we will be making use of these upper bounds while solving this problem. The next step is we have to find zj minus cj. So zj minus cj, which is actually, if you see, zj is what? The product of these two values, that is 0 into 7 plus 0 into 15. So for this column, and minus cj are the values that we have to subtract from the obtained value. Now for this column, if you see, 0 into 7 plus 0 into 15, both are 0 only, and so minus of minus 35 will give us 35. Then 0 into 1 multiplied with 0 into 2, minus 3. So here you will be having minus 3. And the next value is again 0 over here, because 0 into 1 plus 0 into 4. So minus 5. For the first one, it will be the same. Like all these values can be written with a negative sign over here, since the cost CB column is 0. And so here 0 and then 0. This you would have learned while learning about the simplex method, but still I am just explaining it for you. So what is the next step? Here we have two conditions under this, that is evaluation of zj minus cj we have done. The first one is, if all zj minus cj are greater than or equal to 0, then the current basic feasible solution is optimal. It is the same as how we do in the simplex method. And if at least one zj minus cj is lesser than 0, then the current basic feasible solution is not optimal, and we have to go to the next step. And what is the next step? Choose the most negative among the zj minus cj. So if we check for our problem, these are the values of zj minus cj. So here you have minus 3, minus 5, minus 2. we see that not every value is greater than or equal to 0. So we have negative values over here, and we have to choose the most negative value. So we see that minus 5 is the most negative value. So after choosing the most negative value, let it be ZR minus CR. That is, here we have Z2 minus C2 because it is in the column X2. So for some j equal to r, the corresponding non-basic variable xr enters the basis. So what is the corresponding non-basic variable? It is x2. So x2 enters the basis. So we see that this variable x2 enters the basis. Now after finding the entering variable, in simplex method we will be finding the leaving variable. But here the computations are going to differ. So that is the main difference in this problem. That is, we are having theta 1, theta 2, ur. So all these three we have to first find. And after finding them, we have to choose the minimum of those values which will give us theta. So that is the idea of the problem. Now what is this theta 1, theta 2 and ur? Theta 1 is the same ratio that we find usually in a simplex table. We used to find a ratio column. So that is the theta 1. Theta 2 is little different over here. So we will understand this while solving the problem. And ur is the upper bound of the entering variable xr. Here the entering variable is x2 and the corresponding upper bound, that is u2. That will be ur. So 3 is the corresponding upper bound. And there is a note over here. It is to be noted that if all AIR is greater than or equal to 0, then theta 2 is equal to infinity. We know that are the values that are in this column. This is A1, 2 and this is A2, 2. So these values, if they are greater than or equal to 0, either 0 or positive, then theta 2 has to be taken as infinity. So we see that in our given problem, both the values are positive and therefore theta 2 for this problem will be infinity only. So let us now continue this problem. So now the idea of the problem is to find theta. So theta, which will be equal to minimum of theta 1, theta 2, theta 3. Now what is this theta 1? It is equal to, it is the same ratio that we usually find, that is minimum of, let me write that. So minimum of, here we are having xbi divided by air. So let me show you here. So now what is xbi? These values. So the ratio will be 7 by 1 and this ratio will be 15 by 4. So this ratio only we have to write here. So 7 by 1, 15 by 4, which is equal to minimum of, what is 15 by 4 actually? It is 3.7. Now if we see in these two values, 3.7 is the minimum. So therefore theta 1 is equal to 3.7 is the minimum value, and this is corresponding to which variable? That is 15 by 4 is corresponding to S2. So that also we will write. So corresponding to S2. So this is the minimum value. So theta 1 we have found. Next is theta 2. But we know that if all the entering column, that is the matrix Aij for this column, if all are 0 or positive, then theta 2 is by default it is equal to infinity. It is given in the note. So here theta 2 is infinity. Next we have to find u3, that is the upper bound of the entering variable. The entering variable is what? X2. And what is the upper bound? Here u2. So u2 is equal to the upper bound of the entering variable, which is equal to 3. So now we have to find theta. So what is theta? Theta is equal to minimum of theta 1. Theta 1 is what? 3.7, theta 2, which is infinity, u2, that is theta 3, which is u2. Okay, so this is only theta 3. So u2, which is 3. Now if you see which is the minimum of all these three values, 3 is only minimum, and it is corresponding to the upper bound u2. So theta is equal to 3 is the minimum value. So this is corresponding to the upper bound u2. So whenever theta is equal to a value which corresponds to the upper bound, then what is the entering variable? X2. So the x2 is to be substituted at its upper bound and remains non-basic. That is, we have to update the basic variables. So now usually in simplex method, what we will do, we will find the ratio, and whichever is minimum, that will be the leaving variable. But here it is not the same. For this problem, we have a value called theta, which becomes the minimum of three different values, where theta 1 gives us the minimum of the ratio. Theta 2 is given by a formula which we saw here, which we will be using if any of the values is negative. But here both the values are positive, so theta 2 will be infinity only. And theta 3 is the upper bound of the entering variable. Here the entering variable is x2, and so it is u2. Now out of these three values, we have to choose the minimum. And if the minimum is corresponding to the upper bound, then the basic variables has to be updated. After that only we can perform the iteration. All this I have said in this steps. That is, first case will be if theta is equal to theta 1, which corresponds to xbk, then xk leaves the basis. So if theta was equal to theta 1, then we can decide the leaving variable. But if it is not so, then if it is equal to theta 2, which corresponds to xbk, then xk leaves the basis. So here also we can make a decision of the leaving variable. But at the same time, xk being non-basic at its upper bound, it has to be made a substitution. But this was also not the case in our given problem. The case now that we have arrived is case 3. That is, theta was equal to the upper bound, because that was the minimum value. So if theta is equal to ur, xr is substituted at its upper bound while remaining non-basic. So it can be put at 0 level by making a substitution xr equal to ur minus xr dash. So let me explain this to you with the help of the given problem now. So using this, how the substitution has to be made? xr is equal to ur minus xr dash. Now r is 2 because x2 is the entering variable. So x2 has to be substituted to be equal to u2 minus x2 dash. So if you see here, that only I have written x2 is equal to u2 minus x2 dash. Now where this x2 dash will be 0 lesser than or equal to x2 dash lesser than or equal to u2. So now if you see what is u2 in our given problem, u2 is here. u2 is equal to 3. So that we have to make a substitution. So x2 is equal to 3 minus x2 dash. And from this, 0 lesser than or equal to x2 dash lesser than or equal to 3. Okay. So the basic variables will be updated by using the formula xbi is equal to xbi dash minus air ur. I will explain this to you. Now how many basic variables we have here? 2 basic variables, and the solution space is over here. We are updating this solution space only, that is xb. So that is first xb1 for solution space xb1. So that will be updated by xb1 dash minus a1r. R is what? 2 actually, multiplied with u2, because here this is the value r and this was the entering one, so r is 2. So that is what we have done here. Or you remember generally like this. So the new solution space has to be updated. It will be equal to the old solution. Here the old solution is 7 over here. So 7 minus a12 is the corresponding entering column cell value, that is 1. So 7 minus 1 multiplied with the upper bound. The corresponding upper bound is 3. So this. So multiplied with 3. Okay. Similarly, what will be xb2? That is the second value xb2. That will be equal to xb2 dash minus a22 multiplied with u2. So that is equal to, now here the old solution is 15. So as I told you, 15 minus, Here the corresponding value, that is 4. So 15 minus 4 multiplied with the upper bound. The upper bound is this 3 only. So multiplied with 3. So this will give. So what is this actually? 7 minus 3, which is 4. And here we have 4 3 times is 12. So 15 minus 12, that will give us 3. So 4 and 3 are the new updated solution for S1 and S2. Also the solution z0 will be updated with this. So that is actually z0 dash minus, here r is what, 2. So z2 minus c2 value multiplied with u2. And what is this z0 dash? That is the old solution. Here we have it as 35. So 35 minus, what is z2 minus c2? That is this value. That is the most negative that we obtain, no, that value. So minus 5. And then the upper bound, the corresponding upper bound that we had is 3. So that is 3. So that will be equal to 35 minus into minus is plus, 5 3 times is 15, and that's equal to 50. So the new z0 value is equal to 50. Now we have to update this table, that is the initial iteration table, as a new table. So let us form the new table with the updated values. So now we are going to write the new updated table. That is, this is going to be S1 and S2 only. Okay, because we haven't found the leaving vector. So S1, S2. And what are the cost? It is 0 only. That is also same. Now the updated table will be this XB table, because we have the updated values here. That is, we have the value 4, 3. So these are the updated values. So instead of 7 and 15, we will have 4 and 3 in this table. So 4, 3. And also the updated solution, we have got it to be 50. So here the updated solution is 50. And remaining Cj values, all they will remain the same except the updated vector. So now what is here the updated variable? It is x2. So remember the updated column. So this column has been updated. No, these values will be written with a negative sign. Now if you see here, you have 1, 4. And so here you will be having minus 1, minus 4. And here also the updated value will be minus 5. That's all. These will be the updated changes. Remaining all will remain the same. That is, these values remain the same. That is 1, 2, and then 2, 3, 1, 0, 0, 1. Also at the top here we have 3, here we have 2, and here 0, 0. Remaining all values remain the same except this xb vector, that is a solution space, and then the x2, which has to be written with a negative sign throughout in that column. All the others will remain the same. Now next again we have to find the zj minus cj. Since these two values are 0, this will be written this will be 0 into 1 plus 0 into 2 minus 3. And then 0 into minus 1, 0 into minus 4, minus of minus 5, which will become plus 5. And here 0 into 2 plus 0 into 3, which is going to be 0 only, and here minus 2. And here again 0, 0. So now these values we have. Now also we will write the upper bound values over here, UR. What was the upper bound values are same only, 4 and 3 and 3, infinity and infinity. And we should know that we have updated the variable x2 as x2 dash. So this has been updated. That also we have to make a change. So remember, this variable x2 has to be updated as x2 dash. Because of that only, the upper bound we have written here as 3. Because for x2 dash, the upper bound is 3 only. So that is what we have written. So this is x2 dash. So kindly make that change. Now after finding the zj minus cj, we have to find the entering vector. How we will find that? We will see for the most negative. Now if you see, the most negative is minus 3, and so this will give us the entering vector. So x1 enters the table. Next we have to find the leaving vector, for which we have to find theta, where theta will be minimum of theta 1, theta 2, theta 3. So we will do the same procedure now. So I have just written that the entering variable is x1. Now we will find the leaving vector, for which we will find theta. So now we know that theta is the minimum of theta 1, theta 2, theta 3. Whereas theta 1 is what? It is the ratio that we usually find in simplex method. That is the vector xb divided by the element of the entering column, that is 4 divided by 1, and then we have 3 divided by 2. So this ratio, there is minimum of this ratio is theta 1. So theta 1 is minimum of 4 by 1 divided by 3 by 2. So what is this 3 by 2? It is 1.5. So this is minimum of 4 comma 1.5. And obviously what is the minimum? 1.5. And this is corresponding to which variable we have to see. That is this value 3 by 2, which is corresponding to the variable s2. So this is corresponding to s2. So that we will write and keep. Next we shall find theta 2. Now we have to check whether this entering column, so this was the entering column. How are these values? Both are positive. Even if one is negative, then we can find theta 2. But since both are positive, theta 2 is what? It is infinity. It is by the node that we saw already. And then we have to find theta 3. Theta 3 is the upper bound of the entering column. So this is x1 is the entering one. So this is u1. This is u2, this is u3, and so the entering one is u1. So u1, which is equal to 4. Now we shall find the minimum of these three. So theta is equal to minimum of theta 1, which what is theta 1? We have obtained 1.5. Theta 2 is infinity, comma theta 3 is 4. Now out of these three values, which is the minimum? Theta is equal to 1.5 is the minimum, which is corresponding to theta 1, and this is corresponding to s2. That is the ratio that we have found. If it is the ratio that we have found, then we have to look out for the leaving variable. So what will be the leaving variable? So this will be the leaving variable. It is the normal simplex method. So the leaving variable is s2. So this will give us the leaving variable, and the pivotal element is 2. Now we have to perform the same method of simplex method that we do. That is the same operations we do on the table, and we perform it, because this is the entering variable, this is the leaving variable. So first we will change the basic variables that we have here. So I have written iteration 1 here. First will be CB, and first we will write YB, that is S1 remains the same. Now the leaving variable is S2, and what has entered? Entering variable is X1. So we have to replace S2 by X1. And what is the cost of S1 in the objective function? 0 only. Whereas the cost of X1 in the objective function is 3. So that we have to replace. So if you see, we have the objective function here, where the cost of x1 in the objective function is 3. So I have replaced here by 3. You could see that. Next we will be having the solution space xb and then x1, and here x2 dash as in the previous table that we have, and then x3, s1, s2. So these all are the same. Now here also we will write the cost, that is 3 minus 5 we had, and 2 0 0. So I'm just writing it from the previous table. So here 3 minus 5 2 0 0. And now here I need to write the CJ, because here we have 50, and how we have to write the CJ? With the negative sign. So minus 50. So remember, in iteration 1 we have to write the solution that we have obtained 50 with a negative sign at the place of CJ, so that it will be easy for the evaluation. And after writing that, we have to update this matrix, that is we have to perform the operation. I have written the performance of the operation over here for your understanding, but this is the same simplex method how we do previously in our simplex method problems. So the same method has to be followed. That is, we have to form the new pivot equation. Okay, so how the new pivotal equation will be formed? It will be the old pivotal equation divided by the pivotal element. So if you see, this is the pivotal equation. And what is the pivotal element? It is 2. So we have to divide this row completely by 2. So that is, if we consider this as row 2 and this as row 1, so row 2 divided by 2 will give us the new row. So if we say the new row is row 2 dash and this is row 1 dash, so row 2 dash will be equal to Row 2 divided by the pivotal element. The pivotal element is 2. So row 2 divided by 2. That is the old pivotal equation divided by the pivotal element. So if you see, this 3 has to be divided by 2, and so we will be obtaining 3 by 2. And 2 divided by 2 will be 1. And then we will have minus 4 divided by 2, which will be minus 2. And then we have 3 divided by 2. And then we have 0. And then this is 0, and this is 1 divided by 2. So we have obtained row 2 dash. So this is done. Now we shall find row 1 dash. So what is that? Row 1 dash is the new S1 equation, and that is equal to the old S1 equation. So the old S1 equation is this, which we have taken as row 1. So old S1 equation is row 1 minus, the formula is minus its entering column coefficient. What is the entering column? This column. And what is the entering column coefficient? It is 1. So minus 1 multiplied with new pivotal equation. The new pivotal equation is what? This one. This is the new pivotal equation, R2 dash. So 1 multiplied with R2 dash. So you patiently go through this. Using that, I have written this row operations. So row 1 dash we have to find by row 1 minus row 2 dash. So this is row 1. 4. Here we will be having 4 minus 3 by 2. So that will be 4 minus 3 by 2. So the LCM is 2. So 8 minus 3, which will be 5 by 2. So this new element will be 5 by 2. So row 1 minus row 2 dash we have to do for all the elements. This is row 2 dash. Row 1 we have from here. So here 1 minus 1, which will be 0. Then here x2 dash, what you have? Minus 1 minus of minus 2, which is plus 2, which will be minus 1 plus 2, which is 1. And then here you have 2. So 2 minus 3 by 2. So what is 2 minus 3 by 2? It will be, LCM is 2. So 4 minus 3, which is 1 by 2. And then for S1 we have 1 over here. So 1 minus 0, which is 1. And then we have 0 over here. So 0 minus 1 by 2, which will be minus 1 by 2. So this is what we have obtained. So we are done with it. And we should also write the upper bound. We know that it is 4, 3, 3, infinity, infinity. For these variables, we have written the upper bound. Now we shall evaluate Zj minus Cj. It is the same process, that is 0 into 0 plus 3 into 1, which is 3. 3 minus 3 will be 0. And here for this value we have to do 0 into 5 by 2 plus 3 into 3 by 2, which will be 9 by 2, minus of minus 50, which will be plus 50. So it will be 9 by 2 plus 50. So that's equal to 2 is the LCM. So 9 plus 100. So that will be 109 divided by 2. So this is 109 divided by 2. So remember, 0 into 5 by 2 plus 3 into 3 by 2 gives us 9 by 2. Minus of minus 50, which will be plus 50. So 9 by 2 plus 50 is 109 by 2. This is how we got this. Similarly, 0 into 1 plus 3 into minus 2, which is minus 6. And then minus of minus 5, which is plus 5. So minus 6 plus 5 will give us minus 1. And here 0 into 1 by 2, 0. 3 into 3 by 2 is 9 by 2. 9 by 2 minus 2. So what is 9 by 2 minus 2? LCM is 4. 9 minus 4, which will give us 5 by 4. So this will be, 5 by 2 actually. LCM is 2. Okay. So 2 times is 4. So 5 by 2 we will have here. And then 0 into 1, 3 into 0, 0, minus 0, 0. And 0 into minus 1 by 2 is 0. 3 into 1 by 2 is 3 by 2 minus 0 here. So it's 3 by 2. Now we will see which is the most negative. We could see that only minus 1 is the negative value that we have. And so this will be the entering column. That is x2 dash. So this is the entering column. Now for the leaving vector, before that we have to find theta. Again for theta, it will be theta minimum of theta 1, theta 2, theta 3. It is the same method. So first we shall find theta 1. Theta 1 is what? The ratio. So it will be 5 by 2 divided by 1, which is 5 by 2 only. Whereas this we can't do because you have a negative sign over here. So theta 1 is equal to minimum of, we know that this has to be positive in order to find the ratio. So 5 by 2 comma dash. So obviously it is equal to 5 by 2, which is equal to what? 2.5. And this is corresponding to which one? So corresponding to this 2 by 5 is corresponding to S1. So that also we should write and keep. Okay, next we have to find theta 2. But if we have all positive here, directly we can write theta 2 as infinity. But we see that in this problem, I mean in this iteration, we have a negative value. So if you have a negative value, what is the procedure? So you have to find, that is AIR is lesser than 0. So this is lesser. So if it is lesser than 0, then it will be equal to minimum of uj minus xbi divided by minus AIR. So this minus AIR is the element which we had the negative value. Okay, those values which are negative, for that only we have to find the minimum. And we have only one negative value here because the other value is positive. So for this value, we have to find this operation uj minus xbi divided by minus AIR, which will give us theta 2. Since only one value was negative, that was the minimum, and so that will be theta 2. So let us find that. So theta 2 is equal to minimum of, the first value was a positive value, so we should not do it for that value. We should do it only for the negative value. And for the entering, that is the value uj is the upper bound for that negative value. For if you see here, now the negative value is corresponding to what element? It is corresponding to x1. So when this negative value is corresponding to x1, we should see the upper bound for that x1. So remember, not for the entering column. We should not see the upper bound of the entering column. We should see the upper bound of the corresponding negative value. So this is the negative value that we had. For that value, you should see the variable. So that is x1. And what is the upper bound for that variable? It is 4. So that only we have to write here. So 4. So this is only this uj minus xbi. So minus, and what is the corresponding xbi? That is 3 by 2. So for this negative value, corresponding xbi is 3 by 2. So minus 3 by 2 divided by, so corresponding xbi we have found, divided by minus, so minus that value. What is that negative value? Minus 2. So minus of minus 2. So this is how we have to do. So that's equal to minimum of hyphenate. And what is 4 minus 3 by 2? 2 is the LCM. And 4 2 times is 8. 8 minus 3 is 5. Divided by minus into minus is plus. So 2. And so that will be equal to minimum of hyphen comma 5 by 4, which is 5 by 4. Therefore theta 2 is equal to that 5 by 4. But what is 5 by 4? It is 1.2. And this is 1.25, you can take 2 decimals. So 1.25, and this is corresponding to which variable? X1. Because this was the variable. Here. This one. Okay. So that is corresponding to x1. Then one more theta 3 we have to find. What is theta 3? We know that theta 3 is equal to the upper bound. And what is the upper bound of the entering variable? This is u1, u2. And entering is x2 dash. So u2, which is equal to 3. Therefore theta 3 is 3. So theta will be equal to what? Minimum of theta 1. What did we get theta 1 as? 2.5, comma theta 2. Theta 2 is 1.25, and theta 3 is 3. What is the minimum of these three values? 1.25. So theta is equal to 1.25, which is corresponding to theta 2, and that corresponds to x1, and this is corresponding to x1, which means that x1 leaves the table. So this x1 vector leaves the table, and so we have to perform the same operation for this x1 now, because x1 leaves the table. So now we have to perform the next iteration, where we have to write this cb, yb, and then xb, and then x1, x2 dash, and x3, s1, s2. And first we will write yb, that is s1 remains as it is. Now x1 leaves the table and x2 dash enters the table. So here you will have x2 dash. And what is the cost of s1? It is 0. And what about the cost of x2 dash? If you see, we have updated the variable x2 as x2 dash. And what did the cost change as? It changed as minus 5. So remember this. Okay, this will be the cost. So that cost we have to write. So minus 5. Okay, and then now, and since we are performing operations, CJs we can write as it is, that we have in the previous table. Okay, if we update only, we need to change here. But since here it is the same, so that one we will write as it is. So minus 50 and then 3 minus 5 2 0 0. So this is fine. Now next we have to calculate, that is the pivotal element over here is minus 2. So what is the method? We know that the new pivot equation is equal to old pivot equation divided by pivotal element. So now if suppose this one is r1 double dash and this is r2 double dash, the new pivotal equations. And here we have the old pivotal equations r1 dash and r2 dash. This is the pivotal equation. The pivotal equation is r2 dash actually. So the new pivotal equation is our old pivotal equation divided by the pivotal element. Pivotal element is minus 2. So this one divided by minus 2. So that is what I wanted to say actually. So this we have to find by dividing these elements by minus 2. So 3 by 2 already we have. So divided by minus 2 will give us minus 3 by 4. So that we will write here. So minus 3 by 4. And here we have 1 divided by minus 2 will give us minus 1 by 2. And here minus 2 divided by minus 2 will give us 1. And then here 3 by 2 divided by minus 2 will give us minus 3 by 4. And 0 divided by minus 2 is 0. 1 by 2 divided by minus 1 by, divided by minus 2 is minus 1 by 4. So this is what we obtain as the new pivotal equation. And then r1 double dash, that is the new equation of s1 will be old s1 equation. What is the old s1 equation? r1 dash. So r1 dash minus its entering column coefficient. So this is the entering column. Again the entering column coefficient is 1 only. So 1 multiplied with new pivotal equation, which is r1 r2 double dash. So minus r2 double dash. These steps you go through patiently, you will definitely understand it, and you have to try to understand with these two formulas that I have given you. So now here we have to find r1 double dash, which is r1 dash minus r2 double dash. Now here we have r1 dash. So if you see, this is only r1 dash. So first we will see for this element 5 by 2. So 5 by 2 minus of minus 3 by 4. So 5 by 2 plus 3 by 4. The LCM is 4. So 5 plus 6 we will have. So that is equal to 13 by 4. So we will write that 13 by 4. So here we get 13 by 4, and how we got this 13 by 4? It is actually 5 by 2 minus of minus 3 by 4. So if you see 5 by 2 minus of minus is plus 3 by 4, and the LCM is 4, and here we will have 10 plus 3. So 13 by 4, that is how we got, not this one. Okay, so 13 by 4. Similarly for this element, 0 minus of minus 1 by 2, so it will be plus 1 by 2. And then for this element 1, here we have 1 minus 1 will be 0. Next element is 1 by 2. So 1 by 2 minus of minus plus 3 by 4. So 1 by 2 plus 3 by 4, the LCM is 4. So 2 plus 3, which will be 5 by 4. So 5 by 4. Then next one is S1, which is 1. So 1 minus 0, so it will be 1 only. And then minus 1 by 2, minus of minus plus 1 by 4. So 1 by 4 minus 1 by 2. The LCM is 4, and so it will be 1 minus here 2. So minus 1 by 4. So this is what we get. And next is we have to find Zj minus Cj. Now if you see 0 into 13 by 4 is 0. Minus into minus plus 5 into 3 by 4, which is 5 3 times is 15. 15 by 4 minus of minus 50, which is plus 50. So it will be 15 by 4 plus 50. See, minus into minus plus 5 3s are 15. So 15 by 4 minus of minus 50, which is plus 50. And so here the LCM is 4. 15 plus, here you have to multiply 4. 5 4 times is 20. So it will be 200. So 200 plus 15 will be 215 by 4. So this is 215 divided by 4. Now next here 0 into 1 by 2 is 0. Minus into minus plus 5 by 2 minus 3. So what is 5 by 2 minus 3? The LCM is 2. 5 minus 6, which is minus 1 by 2. So we get minus 1 by 2 over here. Next is 0 into 0. Then minus 5. Minus of minus 5 plus 5. So minus 5 plus 5 will become 0. And then minus into minus plus 5 3 times is 15. 15 by 4 minus 2. So what is 15 by 4 minus 2? The LCM is 4. So 15 minus 8. So that will be equal to 7 by 4. So which is 7 by 4. And then 0, and this is also 0, so 0. 0 and then minus into minus plus 5 by 4 minus 0, so it is 5 by 4. So we have obtained Zj minus Cj. Now we have only one negative value, and that is going to enter the basis. So this becomes the entering vector, that is x1 now enters. In order to find the leaving vector, or whether we have to update the table, we have to find the value of theta. And here we have to write the upper bounds 4, 3, 3, infinity, infinity, as usual from the previous table. Now next we have to find theta, which will be minimum of theta 1, theta 2 and theta 3. What is theta 1? Theta 1 is the ratio that we usually find. That is 13 by 4 divided by 1 by 2. So it will be 13 by 4 multiplied with 2. So 13 by 2 actually, which will be and here you have a negative sign, so we need not find this. So it will be minimum of 13 by 2 and then dash, because it is negative. So obviously it is 13 by 2. And what is that 13 by 2? It is equal to 6.5. And this is corresponding to S1. After finding theta 1, we have to find theta 2. So theta 2 we have to find for the negative value. Yes, we do have a negative value. And so that will be minimum of, first we have to write the upper bound of the corresponding variable to this negative value. So this is the negative value, and what is the variable corresponding to it? It is x2 dash. And what is the upper bound for x2 dash? It is 3. So that we have to write. So 3 minus the xb vector corresponding to the negative value. This is the negative value, and the corresponding xb vector is minus 3 by 4. So minus into minus plus 3 by 4. The whole divided by minus of the negative value that we have. So minus 1 by 2. So the minimum of this, comma, the other one is positive. I mean, first we had the positive, so dash. So that will be equal to minimum of dash, comma. What is this here? The LCM will be 4. And 4 3 times is 12. 13, 14, 15. So 15 by 4. And divided by minus into minus is plus 1 by 2. So that is equal to minimum of 50 dash, comma, 15 by 2. And what is the minimum? Obviously it is 15 by 2 only. And what is that value? 15 by 2 is 7.5, and this is corresponding to which variable? So corresponding to x2 dash, because this was the negative, and so it's corresponding to x2 dash. And so now we have found this. Next we have to find theta 3, which will be equal to the upper bound of the entering variable. The entering variable is x1, so the upper bound u1 we have to write. The upper bound is 4 over here. Now we shall find theta, which is equal to the minimum of all the three values, that is theta 1, which is 6.5, comma, the next minimum is, next theta 2 is 7.5, comma, theta 3 is 4. So out of these values, which is minimum? Theta is equal to 4 is the minimum, and this is corresponding to u1, that is the upper bound, which means that the entering variable has to be updated now. So x1 will be substituted at its upper bound. So if x1 has to be substituted at its upper bound, so it will be replaced as x1 is equal to, by the formula as I told you previously, it will be u1 minus x1 dash. So this is the updated variable. So from this we know that x1 will be equal to, what is u1? It is 4. So 4 minus x1 dash, where 0 will be lesser than or equal to x1 dash, lesser than or equal to the upper bound 4. So this is the updated version of x1. Now when this is updated, the basic variables should also be updated. And I already showed you it is updated by this formula. Now there are two basic variables, xb1 and xb2. These two has to be updated. And the method I told you is, the first update for this, we have to update 13 by 4 is the previous xbi value. So for that, 13 by 4 minus the corresponding coefficient of the entering variable, that is 1 by 2. Okay, so 1 by 2 multiplied with the upper bound corresponding to that. So what is the upper bound corresponding to that? 4. So multiplied by 4. So that's equal to 13 by 4 minus 2 1 times, 2 2 times. So minus 2. Okay, so that's equal to, LCM is 4, 13 minus 8, which is equal to 5 by 4. So this is the updated xb1 vector. Similarly, the next one we have to do, that is xb2. So what is xb2? It will be, the previous one is minus 3 by 4. So that has to be updated, no? So it will be minus 3 by 4 minus of, what is the corresponding value of the entering vector? Minus 1 by 2. So that we have to write. So minus 1 by 2, and the upper bound is 4. So 2 1 times, 2 2 times. So that's equal to minus 3 by 4, and then a minus, here you have 2. And if you see, this minus into minus will become plus actually. So plus 2, which is equal to, the LCM is 4, minus 3 plus 8, which is equal to 5 by 4. So this is the updated second xb2. And then the solution is also updated. So that is equal to, what is the old solution that we have? We have here as 215 divided by 4. So that we will write. So 215 divided by 4 minus the most negative value that we had. So it is minus 1 by 2. So minus 1 by 2 multiplied with the corresponding upper bound for that value, which is 4. So 2 1 times, 2 2 times. So that's equal to 215 divided by 4. Minus into minus is plus 2. So that's equal to, the LCM is 4. So 215 and a plus 8. So that's equal to 223 divided by 4. So this is the updated solution. So let us now form the new table, because we usually form a new table after updating the variables. Now here we have the table for the updated values. Here we will have CB and YB as usual, and then XB. But here x1 is updated now. It has been updated as x1 dash. This is already updated x2 dash. X3 remains as it is, S1, S2. And then first we will write what is YB. YB is S1 and the same variable x2 dash which we got in the previous table. And then what are the changes that we have to do? We have to write the updated xb vector. The first value has been updated as 5 by 4 and the second value is updated as 5 by 4. So here you will be having 5 by 4 and 5 by 4. And all the updated column vector will take negative sign, that is these values has to be negated. So 3 will become minus 3 over here. So minus 3. And here 1 by 2 we have, so it will become minus 1 by 2. And here we have minus 1 by 2 and it will become plus 1 by 2. The rest all remain the same as it is, however it is in this table. The remaining all we have to redo it. So we have written all that, and this Z0 is also updated. That also we will fill. It has been updated as 223 by 4. So this is 223 divided by 4. Now for this table, let us find Zj minus Cj. So here 0 into this becomes 0, minus 5 by 2, minus of minus 3 plus 3. So minus 5 by 2 plus 3. The LCM is 2 minus 5 plus 6, which is 1 by 2. And then 0 minus 5 plus 5, it will be 0. 0 minus into minus plus 5 3 times is 15, 15 by 4, and then minus 2. So LCM is 4, 15 minus 8, which is equal to 7 by 4. So this is 7 by 4. 0 and this is 0. So 0. 0 into this is 0. Minus into minus plus. So 5 by 4. Now we see that all Zj minus Cj are positive. That is, they are either greater or equal to 0. So let us write that. So all Zj minus Cj is greater than or equal to 0. So now we have obtained the optimal solution. So therefore we shall find the values of the variables, that is the variables given in the problem is x1, y and x3. And in between we had the values, we have the updated variables x1 dash and x2 dash. So using we shall find all these values, we shall find these updated variables and substitute in order to find the given original variables. So now what was from the table we see that, so this gives us the solution space. So this is the solution space. We see that the value of x2 dash is 5 by 4. So x2 dash is equal to 5 by 4. Using this value we can obtain the value of x2. In between we had this variable y was updated as x2 and then it was updated as x2 dash. So we can find the value of x2 and therefore by back substitution we can find the value of y also. So we will take and do that. So if you see, we had x2 to be equal to 3 minus x2 dash. Please go through the problem previously, like in the previous steps we have this updation. So from that I have taken. So x2 is equal to 3 minus x2 dash. So from this we will get 3 minus 5 by 4. And so the LCM is 4 over here. 4 3 times is 12. So 12 minus 5, which will be equal to 7 divided by 4. So therefore we have obtained the value of x2 to be equal to 7 by 4. And using this value of x2 we can find the value of y by back substitution. That is, we already updated the value of y to be equal to x2 plus 7. In our previous steps this is there. And so x2 is what? 7 by 4. So 7 by 4 plus 7. So that will be equal to, the LCM is 4. So 7 plus, here we have 28 because 7 4 times is 28, and so that is updated as 35 divided by 4. So therefore y is equal to 35 divided by 4. So this is the value of y. So now the remaining is, we don't have x1 dash in this table, and so x1 dash will be equal to 0 therefore. So if x1 dash is 0, we know that x1 is equal to what? In respect of x1 dash, it was equal to 4 minus x1 dash. Okay, so refer to the problem. So 4 minus x1 dash, which implies that x1 will be equal to 4 minus 0, which is 4. Therefore the value of x1 will be equal to 4. And we do not have x3, so therefore the value of x3 will be taken as 0. So finally we have obtained the values of x1 to be equal to 4, x2 to be, that is, and y is equal to 35 by 4, and x3 is 0. So when we go back to the question, we need max z, and so that is equal to 3 multiplied with, what is x1? x1 is 4, so we shall substitute that, plus 5 multiplied with y. What is y? Y is equal to 35 by 4. So 35 divided by 4, plus 2 multiplied with x3. What is x3? It is 0. So when we simplify this, 4 3 times is 12, plus now 5 multiplied with 35, which will be 175 divided by 4. And so the LCM will be 4. And 4 multiplied with 12 is 48. 48 plus 175, which will give us 223 divided by 4. So from the solution space also we can see that the solution was 223 divided by 4. And we can cross check our answer with this. So that's why I have been keeping updated with this value. In fact, you can do the problem without keeping it updated, but I kept it updated in order to check our final answer. So we have observed that we have got it to be 223 divided by 4, which is the max z value. So max z value is equal to 223 divided by 4. So this is the solution, where the value of x1 was to be equal to 4, y is equal to 35 by 4, and x3 is equal to 0. So let us have a quick recap of the problem. So here we have the value y which had a positive lower bound, and so we substituted the formula, and we got a substitution for y as x2 plus 7. And after making that substitution, we reformulated the problem. After reformulating the problem, we have written it in the standard form by adding the slack and surplus variables. I mean, a surplus variable was not necessary here. Only the slack variables were added, and we have differentiated the basic and non-basic variables we have shown. And after that, we formed the initial iteration table, and we found the entering vector. And after finding the entering vector, we had to find the value of theta, which was taken to be the minimum of three values, theta 1, theta 2, theta 3. And since it was corresponding to the upper bound, we had to update the values of the basic variables. And so we have updated the table, we have updated the basic variables, and we formed the new table. And in this table, we performed the zj minus cj operation, and we found the leaving vector, and we found the entering vector and the leaving vector. And after finding the entering vector and leaving vector in the same method, by finding the minimum of all the thetas, we have got the entering vector and the leaving vector. And introducing the entering vector and dropping the leaving vector, we formed a new table. And again, we performed the zj minus cj operation for this table, and for this also we have found the entering vector and the leaving vector. And since here the entering vector was corresponding to the theta value, which was corresponding to theta 2, so we had the leaving vector, and so we dropped the leaving vector, and the entering vector was x2 dash, and we performed the zj minus cj, but we found that the minimum of theta values was corresponding to the upper bound. And since it was corresponding to the upper bound, we made a substitution, and we updated the basic variables again. And after updating, we formed the new table, where we found all the zj minus cj values to be positive or 0, that is greater than or equal to 0. And since it was so, we found the values of x1, y and x3 by using the method of back substitution, and hence we have found the value of maximum z, which was equal to 223 divided by 4. And this was also found in the table, solution table, so that also you can verify. And here we have the steps involved in the bounded variable algorithm. So kindly go through the steps patiently. And here we did the zj minus cj in this in the simplex method, but the difference came here only, that is finding the theta 1, theta 2 and theta 3, and taking the minimum of all the three. That was the difference over here in this problem. And then having the three cases, if theta was equal to theta 1, there would have been a case. If theta was equal to theta 2, then the case was different. We will be finding the leaving vector. If it was the third case, theta is equal to the upper bound, then we will update we will make a substitution, and the basic variables will be updated by using this formula. So this was the method. And as a conclusion, go to step 5 and repeat the procedure until an optimum basic feasible solution is obtained, or there is an indication of an unbounded solution. And if any variable is without its upper bound, then assume that the bound is infinity. This is one of the note you have to make for this problem. So I hope you would have understood how to solve a problem under bounded variable algorithm. Kindly go through the problem patiently. You will definitely understand it. Thank you.